of our workshop before the roundtable. So we have the pleasure to have from Thales either Marko, Erman, who is Chief Scientific Officer in Thales, leading quantum technology research and development, and also Paolo Bortolotti, who is Thales employee, but leading the Laboratoire Albert Fert, which is a joint unit between CNRS and Thales, and also leading the spintronic factory network. So the floor is yours.
Thanks a lot. Let's go. So it's the last talk. We took some, we have some delay. So hopefully I'm not gonna take a lot of time, because if I think of all the talks we have seen today, most of the things has been discussed already. There is maybe something we can talk about. It is the opportunity for radio frequency, and in our case, in particular, for defense. So it's clear that we have seen many times that energy efficiency is an issue. We see in previous talk that artificial intelligence will make this problem much higher. And at the end, we have a quantity of data that we have to treat that is going to be unbelievable. So we have to do something else. Nello proposed some solution. There are some other ideas. What we want to present here is that maybe thinking of analog computing can help. And I'm saying that because as Thales employee, we have some interest in defense, and when we are talking about defense, there is the need of being able to treat fast and in a secure way a lot of data, for example, radio frequency data. And that's why what we need is something that is compact, low energy consumption, ideally autonomous, and we live in Europe. There is a question of sovereignty, has been said in the beginning, so made in Europe. And we believe that spintronics can solve some of these issues. And the second point is that spintronics can also help because, as we have seen, we can do sensor, we can do memories, we can do in-memory computing then, but we can do other things too, and we can combine all this in the same platform. And this can really be a game changer in the next period. And as I said, I insist, we need an industrial European supply chain. And we have to work with the actors in Europe in order to, and also in France, via France 2030, to do something to be there and build together this supply chain. What is the key point? The key point is the same. We have seen many times today. It is the MTJ. The MTJ is such a nice little object that we can do memory and we can play with that. And we know, here I put Samsung. I could choose, but the presentation was sent yesterday, some slide from Global Foundry too. And we know that there are some solution available. Compact, low power, CMOS compatible. But what maybe we didn't see too much, only some input this morning by Lucian, is that we can also do radio frequency. So the same object can be useful to inject an RF signal or to detect, and we can play with that. And then, so with practically the same object, we can do memory and we can do RF dynamics. And so what we are working a lot in the lab with collaboration with several partners in the world, but in Europe in particular, is to create a neural network, artificial neural network. So we use this simple object, the MTJ. We can do a synapse, we can do a neuron, and then if we have this key ingredients, we can play with that, and we can do artificial neural network. And so we have proven that this is possible, and now we have to scale it up, that's clear. But the opportunities we consider are huge, because what we do usually is that we have to digitalize the signal, and then we do operation on that. And instead, with such artificial neural network, we can, in principle, be able to do directly, to treat directly. Oh, okay, all right. It's enough. It's the last one for me. So we can treat directly all data, and without doing this digitalization, we can extract some information. For example, we have some raw data RF, and we can play with that. No, I forgot. I'll be fast. Okay, so we have this, and the second thing is that we can do many things. Erman, we said, we can extract information for the direction of arrival, and we can also do another thing. We can add security with the same MTJ, stochastic, has been discussed today. And we can even have an energy harvesting. We have proven that is possible. So when you have all these ingredients, you arrive to understand that we can have tomorrow an object, spintronics, where all things are integrated: security, RF neural network, in-memory computing, interferometry, and many other things. And so this is where we hope will go the RF. And I pass.
Yeah. Thank you. Good afternoon, everybody. I'm afraid these are a little bit less specific figures than your car industry. There's a little bit of army there on this slide. I'd like to illustrate for you what are the trends in the defense system today. The systems become more and more complex in terms they are system of system, with a lot of interconnection, with a lot of points of autonomy. It's not the whole system that is autonomous, but they are islands of autonomy. There's timing where the things can be autonomous. And actually, these things work. You have to work in what is called the three milieu, the air, land, sea. So you have a number of kind of different platforms, big, small ones. And the things that is absolutely obvious, of course, I mean, on the army, you don't have a power station to power up your stuff. You bring your batteries and so forth, which means that miniaturization, frugality, and even lower cost is very important. We saw with let's say, the last conflict, the recent conflict, the importance, even increasing of the countermeasures, how you actually detect all of the radio frequencies in the air, how you counter the drones. We saw massification of the arms. I mean, the number of drones, hundreds of drones arriving at the same time. And also, let's say, what we call the augmented soldier, which is more and more, let's say, empowered by technology soldier. So from a general concept, it's very obvious that high performance, low power, multifunctional AI devices, multifunctional in the aerospace, are of great interest for the defense. Today, the kind of things we are doing at Thales, like sensors, well, these are bigger sensors than from cars, radars, sonars. In between, you have a radio for the vehicle. On the bottom, you have a control center. This one is for cyber. And there are other functions that I will not read. You can see on the slide. But the value proposition of spintronics is great. Now, of course, there are challenges. The potential is there is no question about it. We said numerously times. The fact that there are a number of applications also is very obvious. But they are challenging. And this is maybe just the bridge to the roundtable discussion. Funding. When we go up to the market, I mean, the funding change scales. The scaling up of technology itself is a challenge. And of course, manufacturing and supply chain, in particular in the defense constrained when you put all this together. So this is, in a nutshell, what could be the use in defense of these kind of systems.
Thank you very much. Questions on this presentation? So you mentioned that potentially, namely maybe on AI, there are some added value from spintronics. Vincent mentioned at some point some particular attributes of magnetic materials in terms of sensitivity or non-sensitivity to irradiation. So is this of interest, or only the low power that is brought by...
This could be of interest for space application, as it was mentioned, of course. But indeed, the volume, the market is today quite small for this kind of application. But as a property, this is a good one.
Okay.
But I mean, just to give you one example, for one of the applications that we meet, which we will not mention precisely, but one of the applications that is embedded on a platform, I'll call the manufacturer, the NVIDIA processor was 10 times too much power consumption. So we have developed our own chip for the Embark AI. So it's not just that you can actually take from what is available on the civilian part and then put it on the military, because the constraints are quite different. Now, power consumption is one, but then the security, the resistance, reliability, even the algos themselves might be very specific.
And about the maturity of the technology, because potentially bringing something breakthrough, but which is not well enough qualified, may be detrimental for transferring to...
Well, I mean, soldier will not take the risk to put something that is not reliable or that has, let's say, hidden problems. So, like, putting smartphone on the hands of the soldier, that would not be a good idea.
Okay, so if no other question, thanks the speaker again.